Hello everyone. Today we are doing the 8.5 lesson. We're going to be adding and subtracting rational expressions, and there's no way to sugarcoat this. This is not easy, okay? Multiplying and dividing, that's not too bad because you just multiply across the top, you just multiply across the bottom, nothing has to match, you reduce, you can even reduce before you multiply, so that's easy. Adding and subtracting is harder. So I put a little reminder for y'all about just adding fractions in general, because that's what we're doing. We're adding rational expressions, which are just really hard fractions like these down here, okay? So way back in the day, you guys learned how to add fractions. And to add fractions, you have to have a common denominator. That's what makes adding and subtracting harder than multiplying. That you have to have them set up with common denominators before you can add. So you have to think, okay, what number could I turn a 2 into and a 3 into so that they would match? And to make them the same number, you have to do that by multiplying. So we're going to turn them both into a 6. And so to turn this one into a 6, we would multiply it by 3. Just make sure you do the same thing to the top and bottom. Whatever you do to the bottom, you have to do to the top. So that's now going to be a 6. And to make this a 6, we're going to multiply by 2, top and bottom. So this problem changed to 3 over 6. See, that's a half. All we did was rename a half. Plus 4 over 6. All we did was rename 2/3. And now, since the base matches, the denominator matches, you just keep that same denominator. Do not add them and get 12. And all you do is add the tops. So it's 7, 6. You can leave it like that, improper. When you were in elementary school, you learned how to change that to a mixed number, and it kind of gave kids the impression that improper fractions are bad. There's nothing wrong with that answer. The reason we change them is so we can find that, like on a number line or on a graph. But if we're not graphing, then you can just leave it as an improper fraction, like that. Okay, so we're starting off easy. They have a common denominator already, 5x, 5x. So as long as they match already, all you have to do is add the tops. So leave the bottom, 5x. They already have a common denominator. Remember, do not add them and get 10x. We're adding 3 of these plus 2 of these. So there are 5 of these, okay? It's kind of like that, not really, but 3 5x's plus 2 5x equals 5 of those. All right, so then this can cancel. See, there's no pluses in there, right? And so the 5s can cancel, and you have 1 over x. So that is your answer. They may ask you for a restriction on the variable, so just remember, x cannot be 0, because then you'd have 1 over 0, and that's undefined. So just pay attention to whether in the problems they ask you for restrictions or not. All right, example 3. So see, now it gets a little harder. The bottoms do not match. So we have 2 over x plus 3 over 4. You have to have a common denominator. You have to make those bottom numbers match. Okay, so basically the rule of thumb is they have to have what each other has. In other words, this x has to have what that one has. So it has to have a 4. And this 4 has to have what that one has. So it has to have an x. That's kind of the rule of thumb. To make a match, like if you had 2 different people who had, I don't know, let's say you gave birthday gifts and they have different birthday gifts. Well, and you want them to be the same. Well, you have to give person A whatever person B has, and you have to give person B whatever person A has so that they match, so that they have the same gift. So I don't know if that helps, but it's just a visual. All right, so this x has to have what that one has, so it has to have a 4. Now remember, we're multiplying. So now this is a 4x on the bottom, and this is just a 4. So this one has to have what that one had, and that one had an x, so we have to give it an x. And now they match. They both have a 4 and an x, 4 and an x. Just remember, whatever you put on the bottom, you put on the top. Whatever you put on the bottom, you put on the top. So this is 8 over 4x, and this is 3x over 4x. Now, don't cancel that, the x over x, not yet, because then we won't be able to add them. See, the whole purpose is that we want to add these. So now that their bottoms match, 4x and 4x, their denominators match, you just bring it over. Do not add them. You add the tops. And you can't really add 8 plus 3x's because they're not like terms. So you just write 8 plus 3x. And that's your answer. Because you can't really combine those. All right, so they may ask you for restrictions on the variable. Just remember that x can't be 0. And then it gets a little harder than that, okay? If the bottom can be factored, then you have to factor it to be able to see what the bottom has. See, so this is simplified. There's nothing you can do there. I'm just rewriting it, 2 over x plus 3. This one factors because we have an x squared and an x. So what that means is that I can factor out an x from each of these terms. So it's going to involve some factoring. If you bring out an x, write down what's left. I'm factoring out a GCF is what I'm doing. So when I factor out an x, that leaves an x. And then when I factor out an x, that leaves a 3. Okay, now you can see what the bottoms have. Okay, this bottom only has an x plus 3. This denominator has an x and an x plus 3. So just remember, you have to give this one what the other one has. So this one needs another x. And you also put it on the top, okay? And now they match already. So you don't have to give this one what the other one had because it already had an x plus 3. All this one had was an x plus 3 and this one already had that. So see, now they match. So the bottom, you leave it x times x plus 3. You don't have to distribute that back again. In fact, I never do. I just leave it factored. And then this, the top, that's a 2x. I wrote x times 2, but that's 2x. And I'm adding 5x. Since they're like terms, you can add them, and you get 7x. Okay, now, this is the reason why I don't like to multiply it back again. I can now cancel this x because there's an x on the top and there's an x on the bottom, in both cases multiplied by the other part of the problem there. And so on the top you have a 7 and on the bottom you have an x plus 3. And so that is how that simplifies when you add them together. If they ask you for restrictions, x can't be 0 because there was just a plain x on the bottom, and x can't be negative 3. So if they ask you for restrictions, just remember you can't have 0 on the bottom of fractions. Okay. Next one. So again, this has to be factored so that we can see what they each have. This would be a good place to stop the video and then try it and see how you do. So this one I'm just going to leave it alone, negative 5 over x minus 2. This one I'm going to factor the bottom so I can see what it's got. Both terms have an x, so I'm factoring out a GCF. When you take out one of those x's, that leaves an x. When you take out the x, that leaves a minus 2. So now you can see what the denominator has. It has an x and it has an x minus 2. This one just has an x minus 2. So we have to give this one what that one has. This one needs an x. So it's just like example 4, exactly like it. Okay, so now they match already. And see, sometimes you have to give both of them what the other one has. In these last two examples, we only had to give this one what this one had before they matched. So x times x minus 2. And on the top, it's not an x minus 5, y'all. This was a negative 5, and I'm multiplying it by x. So that's negative 5x. You might want to write that, negative 5x. Plus a 3x. And then those can be added together because they both have x's. And you have negative 2x over x times x minus 2. Once you get to this step, you can cancel. Because see, these are multiplied and these are multiplied. So you can cancel those x's. Negative 2 over x minus 2. You cannot cancel those negative 2's. You can't, because this is an x minus 2, and you can't take part of that away. All right, the last one is probably the hardest one, because we've got to factor both of these to see what they have. So this is one of those difference of squares that should factor pretty quick. If there's nothing in the middle, it means that they're opposite numbers, x plus 5, x minus 5. So that's going to help in these last couple sections, being able to factor problems like this quickly. See, that's a x plus 5. Sorry, my puppy is happy that my daughters are home. X plus 9, x minus 9. Delilah, shh. X plus 2, x minus 2, x plus 10, x minus 10. See, these difference of squares, they factor quick like that. So that will help you on these last couple sections when there's so much factoring to do. This one, so think of all the ways to get a 5. 1 times 5. Oh, there's only one way to get a 5. And they add to be 6, so that factors pretty easily. And now we have to give each one what the other one has. Okay, now they already share part of the denominator. They already both have an x plus 5. So that part already matches. You don't have to do anything to make that part match. But this one needs what that one has, so it needs an x plus 1. This one needs an x plus 1. I'm going to write it behind it. And so now they both have an x plus 5, and they both have an x plus 1. And then this one has an x minus 5, so I have to give this one what that one has. This one has an x minus 5. And I'm going to put it on the top. Okay, so now they both originally had an x plus 5. No. And I had to give this one the x plus 1. And I had to give this one the x minus 5. And now they have all three of those. All right, so on the bottom, I am not going to multiply that back. I'm going to leave it separate. Multiplying it back again, I just think would be a waste of time. So just leave it all separate, because we need to see them separate to see the restrictions on the variables anyway. And then here on the top, we're going to distribute the 4. We're going to distribute this, be careful about. We're distributing the negative 6. So we have to be real careful there. So 4 times x is 4x. And then 4 times 1 is 4. And then negative 6. See, that minus goes with that 6. Be careful here. Negative 6 times x is negative 6x. And negative 6 distributed to negative 5 is positive 30. And now the reason I multiplied that and distributed is because I needed to check to see if any of this can be combined, because the top is the part that we add together. And this stuff can be combined. We have 4x's minus 6x's, so that's negative 2x. We have a positive 4 and a positive 30, so that's a positive 34. And on the bottom, we just have all those separate binomials like that. Okay, I want to real quick show you that plus 30 again. See, it was a negative 6, and I'm distributing it to a negative 5. That's where the mistake comes in, is that sign right there. It's a positive 30. All right, so nothing you can do here. That is your answer. It's kind of a big ugly one. Look at all those restrictions. X can't be negative 1. X can't be negative 5. X can't be 5, so they may ask you for those. All right, so like I said, addition, guys, not easy. You have to be able to see what the denominators have so that you can make them match. And that is tough. All right, so that is all there is to lesson 8.5. Y'all have a great day. Bye.